many of you have ever faced a situation you're doing a high value transaction, waiting for an OTP to come, and you don't get it like next few seconds, you check your mobile, is the network on? And then all of a sudden you get two messages back to back. Now you're confused which one to use, or maybe you don't get it all. Ever been in that scenario? Yes. Good, then you're in the right session, because that is what exactly I'm going to talk about. How can you do something not like this? How can you architect a system which works at scale? All right, so quick note about me. I bring 2 decades of experience working on scalable systems. Very recently, I have started exploring Gen AI, the AI agentic, not because everyone is doing, because my product demands it, and that is why I had to venture in that situation. By the way, I work as a senior architect for a company that's on my t-shirt. It's Simpplr. We are the Gartner last 3 years in Magic Quadrant as a leader. So continuing with this, how many of you have used microservices? I'm sure you can empathize with this, right? Because you know the pain. So quick context setting. This is a product who wants to get into notifications. Hundreds of microservices, a multi-tenant SaaS platform. They want to venture into different notification patterns like email and Slack and Teams and whatnot. Millions of messages, but they are going to be bursty. There is no fixed rate at which messages will come. The last 3 are very important. The way they say, right, your constraints help you define the architecture, not the real requirements. Requirements are important, but constraints help you define the architecture. So this team, they had a small DevOps team, which means they wanted a solution which is low maintenance, right? They do not have a lot of money to invest on the high maintenance architecture. Cost aware, typically we know how it works, right? We give a solution and then we have to optimize the cost. In this case, they wanted a solution right from day 0 which has to be cost optimized. And of course, this product was built on AWS. They had tie-ups with AWS. So AWS first was a default strategy. But what exactly are we trying to send? I know we are going to send some messages, but this is going to be a multi-tenant solution. This is being used by the enterprise users, not like a B2C kind of thing. This is a B2B2C, you can think from that perspective. So the enterprise users are the ones who are going to use it. The way I said, hundreds of services wants to send the features because they want to promote the adoption of the product, right? So every feature, they want to send notification for some of the other functionality. User, and the way I said, this is like an admin, a multi-tenant. So as a tenant, I have the option to disable notifications being sent for a functionality. A layman example, we all are using Insta, Facebook. You write a post, right? People like it, and then you get a notification, and then it helps you. Okay, somebody has responded to my comment, or like they have liked it. Let me see who the person is, right? So it tempts you to get into the system, so you use the application more and more. So that was one of the reasons they wanted to push heavily on this. But as a tenant, I have the option to configure that if somebody is liking the content, do not send emails or do not send SMS for whatever reason. So like this, for every functionality, as a tenant admin, I have got full control on what kind of notifications I want, or maybe I do not want. Additionally, as an end user, like as an enterprise user, I have more control that I love writing content, but I do not want somebody liking my content, but okay, I want people to like my content, but no notifications for it, right? So as a user, I can go and customize it. Now, there will be some messages which are like very high priority. You are trying to log in, you are waiting for an OTP. So those kind of notifications, they need some SLA. It has to be sent in like 2 seconds, 3 seconds. But think of a situation where somebody liked your content, even if you get after like a minute, it is still okay for you. You're not waiting for it, right? So there has to be a classification like what is important and what is not important. Again, a template-based system, these tenants, they are very, very particular about the branding. So they have a header which will have their logo, some primary colors and secondary colors and whatnot. So additionally, the templates are very important, and the way I said, SLA is of course going to be very important. So this was the situation that we were, and being an architect for such a long time, working with teams, you can easily feel that what could be a logical solution to it.
The system has to be elastic in nature, not just scalable, it has to be elastic in nature. We want to decouple the system. That means I have to introduce some kind of a queue system for people to just dump the messages and then kind of forget it. So this was our first attempt. As a layman attempt was very, very simple. A stateless service. We expect services that, oh, you want to send a message? Just go for it. You have the message. You know if the user preferences are okay, not okay. Depending on that, create a template. Give me the final version that you want to send. Just publish the message into something called as SQS. So AWS has this beautiful, highly scalable functionality called as queue. Just dump the message into SQS, and then there's something called as Lambda. Again, a serverless scalable compute with the pay-as-you-go model, again given by AWS. So the idea is simple. Services push to SQS, Lambda consumes it. Lambda knows how to deliver to emails, Slack or SMS providers, whatever it is configured. So in this case, the idea looked very promising, but there were problems. The problem was there was a tight coupling now being introduced. Why? Tomorrow, if I want to move away from SQS, let's say I want to introduce MSK, which is the, again, from AWS, I cannot move away from SQS because now I have got hundreds of people pushing data into SQS. And for people who have worked on microservices, now if you say, can you please move to Kafka? I'm not moving it. Like, then you have to coordinate enough. And just imagine working with 100 teams who have got their own priorities. This is going to be a nightmare. And then working with the credentials, every person, like every service has to have its own IAM credentials. Managing is going to be a nightmare. Producers, we are kind of revealing our internal implementation that we are using queue. No policy control. Again, who is accountable for ensuring that if a user has configured no mail for likes, who is ensuring it? The domain services. What if they forget? And just think from a perspective, as a tenant user, I have configured no for this feature, it works fine, but for this, it is still sending me the email. So it doesn't go well with the experience of the user. It's a big time hit on the experience. So no central accountability. And of course, like no validations in terms of what are you dumping in the queue? Is it valid? Is it not valid? So net, it was a good attempt. We hit something very important, that it has to be queue because it has to be a decoupling thing, but then not everything went well. We did a revised model. So one thing which I forgot in this is, with the messages, the way I explained, there are some messages which needs an SLA. Now there are some messages which may not need an SLA. It's more like a marketing thing. So some service can publish like tons of messages, and in the queue you have got those messages over here, but then after 1 lakh of messages, you have a OTP message. Now just imagine, by the time you clear the first lakh of messages, the OTP is already expired, right? So it did not go well. So then say, okay, why don't we improvise on the SLA part? So we again landed creating the same thing. Let's have a queue for high priority items. Let's have a queue for low priority items. Or maybe let's have a queue for Slack, because Slack may not be like having hundreds of messages, because not every user will integrate with Slack, but then every user will have an email, they have a mobile number. So we have like now dedicated queues for the providers, for the channels, and again the priorities. This worked well to some extent, but again, the rest of the issues were still intact, right? We still are tightly coupled. There is no central governance, there's no central accountability. And that is where we decided that this is not working. A lot of brainstorming sessions, and finally we landed something like this. A stack full of AWS tech stack with zero maintenance, I would say. I'm just kidding. Less maintenance, it cannot be zero. Less maintenance, but then that was my initial ask also. I have a DevOps team who doesn't want to maintain a high solution, right? So API gateway, again from AWS, that does all the standard API gateway routing capabilities. We have something called as authorizer Lambda. So this Lambda is the one that does all the authentication checks. So rest of the services, they were calling API gateway, and there were JODs, JSON Web Tokens. JODs is what you call. So they were passing JODs. I'm not getting into how the security was managed, but then they were passing JODs, and then the authorizer Lambda was verifying if the JOD is okay or not. Once everything is done, API gateway sends the request to ingestion lambda. Ingestion lambda does very basic checks. Is the tenant for which the messages are being sent, is the tenant active? Now, it would be very stupid for me to send notifications to a tenant users who is no more with the company. But this has happened multiple times. Domain services, oh, we forgot to check. Okay. And your customer says, dude, I'm not there with you anymore. Why are you sending messages to me? So the ingestion lambda does very basic checks, schema checks. If something is priority is missing, is mandatory is missing, it responds back to the callers that a well attempt, but you are short on something. I'm rejecting your request. If everything goes fine, ingestion lambda just pushes something to called as an intake SQS. Now in this case, we decoupled to a great extent because now your services don't have to wait for the actual sending of the messages. For them, the intent is as quickly as possible, I can get my data into the intake SQS. And SQS, it scales very well. They can accept like thousands and thousands and thousands of requests per second. And that was the ask. You remember the burst pattern, right? So that is where this architecture shines. Now, once I have got something in intake SQS, my next is the router lambda. Now, router lambda has got only one thing to be done. We are following single responsibility pattern. It does one thing and it does one thing very well. For this kind of a message, where should I route the request to? Like which specific SQS? Is it a high priority? Is it a low priority? On top of it, there are some customers like tenants who are very demanding. They're saying that I'm okay that for rest of the tenants you are giving 3 seconds SLA, let's say for OTP messages. But for me, it has to be less than 1 second. Now, how do you handle that? Because this is still a common queue for all the tenants. You have the option to create tenant-specific queues as well, and that's where router does the job. Router knows that for this tenant, in which queue I have to push the message. And once it does, it lands onto the next thread, which is the SQS. We are playing with SQS lambda, and that's the beauty of this architecture. So once it goes to the final queue, now you have got a specific lambdas. We're calling them as like delivery lambdas. They know how to read from the queue. AWS already provides the integration. You can just configure that for this queue, this is a lambda. The gelling is done, and then it just works automatically. You don't have to like a pull. The messages are given to you automatically. Just lambda has to just act upon top of it. So that's it. And then we have a DynamoDB, again a serverless aspect of AWS. We're just maintaining a state. Services send the message, lambda deliveries, they send to email or whatever it is. And then we just mention the stage that, okay, we have got state saved. This worked until it did not. Again, why AWS Lambda? The way I said in the previous talk also, sir also mentioned that this is going to be a scalable solution. You just pay as you go, and our workload demanded for it, and that is why we went for it. So all those ideal situations, we are not paying anything extra. We are just paying only for what we are using. And this is where reality hits. Things were working, was well tested, everything was fine, but then eventually it breaks, and that is how we love, right? I mean, we just don't create once and forget it. So things did break. My lambdas can scale infinite, the way AWS claims, but it can scale infinite. It can scale like elastic behavior. Unfortunately, my downstream services, SES cannot, right? Or the other providers for sending SMS, they cannot. Now why? And because of that, what was happening? My traffic is spiked, lambda is spiked, downstream services started throttling, 4 to 9 error. Everyone went into that retrial loop, and eventually it hit my SLA. Now in that case, I was very happy that I have a scalable solution. Lambdas can scale like anything, man, but they're not the downstream services. And that's what our first struggle, that we had to control how much scale we want to configure. And Lambda gives you the option that you can configure concurrency, that this Lambda can only go up to 10 instances or 20 or 1,000, whatever you want to configure, but then you have an option. That is what we forgot. Second, Lambda has an option to say that, give me 10 events from queue. You can have like 1 by 1 as well, but then 1 by 1 has got its own problem. So we went, okay, why not pull like 100 events in one shot, process it. But then if something fails in between, let's say we process 99 and then last one failed, how do you handle that situation? Do I need to retry? How do I commit? Like what do I tell to the SQS? Are you done? Are you not done? So that was giving a lot of problem. And that's where I said efficiency and reliability. These are like the trade-offs that you have to make. So you have to fine tune on what is the batch size that we have to handle. And this one I talked about, where there were contention in the priority. So we had to have like queues very specific to channels with the right priority. And then of course we did a lot of other hardenings. What the Lambda memory should be, the DL queue, if something is not delivered, how do I handle that situation? So you have like a dead letter queue, which you can configure, the concurrency which I talked about, and how do you retry? Do you retry once, twice? How do you retry the back off and everything? So far, we did excellent. The services were doing great. They were very focused on the domain logic. This notification service was very much focused on the templates and whatnot. And then comes a client says, I have not received the email. And domain service said that I have done my job. Talk to notification. Notification service says, in my system, I have sent it. It's your problem that you have not received it. So you see, we are done till end, but it's still not covered the entire loop. And that is how we close a loop. So all these external providers, they give you the option that when SES as an email provider or some other SMS provider or Slack, when they receive something, they acknowledge that the SMTP server was down, I cannot receive the message. Or the email was invalid, it's a hard bounce, I cannot receive, I'm declining. So that feedback is something that we started receiving. SES provides a native feedback by email service. Once it gets a response back from the target SMTP service that I cannot deliver because the inbox is full or maybe message is not correct, it responds back to the email service via the MX and TXT protocol. Email service publishes the event to SNS. SNS again a notification service from AWS, again is scalable. SNS delivers a message to queue. We are literally playing with queues. So SNS delivers a message to SQS and my favorite Lambda. So this Lambda reads from this queue and it updates the DynamoDB. So now we close the entire loop. And this makes our life very much easier for the support people, because now they know that if somebody is saying, I've not received an email, they can just go into the DynamoDB and then can see that, okay, an attempt was made, your SMT server declined it. Why? The reason is there. So everything is working as expected. SES is native, but then all the external ones, we go with the webhook option. So we provide webhook APIs, again via our favorite API gateway. The external providers, they call the APIs that this is done, this is not done, and then we again track it. And we were honestly very happy again until this. Then comes the special use case. And this was really very special. Some of the EU customers, like European customers, they are very strict on something that we would really want to go to, but then they say that, you know what, don't send me emails after 6 p.m. Like, why? No, we have a policy, you cannot send me anything after 6 p.m. Not every customer, but then they have some laws that the labor laws are very strict in EU countries especially. So I work for 9 to 6, you can send me anything and everything between 9 to 6, but nothing after that. Now we have a problem because all the domain services are sending to me, I'm relaying as is, but now I have to pause, I have to break my logic, and then I have to check further that, is the tenant on a specific governance? If yes, I have to hold that stuff, make some adjustments in the DynamoDB that this is still pending to be delivered, and then the moment the 9 a.m. comes, their time zone, I have to read all the emails from all the users who were pending, and then I have to deliver. Sounds very easy, and then Lambda is a solution, right? Unfortunately, Lambda cannot work here because Lambda has a timeout of 15 minutes. And this process is going to take more than 15 minutes, so we literally could not hook onto it. Then came again a serverless option from AWS, which is Fargate. So Fargate is again a serverless compute offering to run containerized loads, like pods and Kubernetes, and you would have heard about all those aspects. So you can run a container as part of a Fargate service. You don't have to pay for anything upfront. You just pay for only whatever you've used. So we wrote a container on-demand launch, depending on when the time hits for the customer. There is no 15 minutes hassle. This can run for like hours and hours. Eventually, we again hooked on to serverless, but then this is a different serverless stack. So the key is your hybrid serverless model still works. You don't have to use the same stack for everything. Depending on the situation, depending on the use case that you have to work. And then finally, this is the final thing that we were able to roll out, which works for us. We have gateways, like we have a control plane that does all the ingestions of the events from the services, from the domain services. Domain services don't have to worry in terms of how delivery happens. We have got all the checks in terms of security. State is well being managed in DynamoDB. We have a data plane who does everything. We talked about the priority queues and channel specific queues and the delivery lambdas. We have a feedback plane to close a loop. Like SES has this native, but then we have got webhook API approach for the rest of the functionalities. And then we have got tracking lambdas who listen to those and just dump into the DynamoDB. That makes our life easier for the support people, the support staff. And of course, we talked about the special compute use case, right, where Lambda just couldn't work, right? More than 15 minutes was a reason. And then finally, the key takeaways. Don't try to retrofit serverless everywhere. If you have a situation like the way we had some constraints defined initially, serverless is going to be a great help. Elasticity is important, but do check, can your downstream services scale well? AWS can scale like anything, but the dependent services also have to scale. With messaging, you have to ensure that you are dealing idempotency well. Domain services can make mistake. They can trigger the same event twice for, let's say, a network glitch, but you as a network, as a notification platform, as a service, you have to ensure that you are identifying those events, and then you are ensuring that you are finally accountable for not goofing up. Doesn't mean that this is like 100% no duplicate email, but even if you strive for like 99.99, that is also fine. But then we are calling it out that this is how we are, and we cannot like assure 100%. And then yeah, I mean, rest is we just discussed. I went a bit quick because of the time which I was being constantly asked for, that we are short of time, but I'm available for any questions. I do not know if you have time for questions, but I'm available for the questions. Yes, and my friend is raising. I'm going to kill you. Okay, the person who's asking the question is my real friend. We are friends for last 20 years, and this is not a cooked up question. I'm going to kill you if you ask me something stupid. Okay. Why should we have two? Okay, that's a very easy question. I can take that. Just kidding. Okay, so the question is, why don't API gateway directly ingest to intake SQS? Like that is what we call as a storage first pattern. The problem with that is you cannot now ensure that if something is being ingested right or not. If you have a schema failure, or if something is being mandatory but is not being passed, how would you communicate to the services? You can still communicate, but now every service have to provide you either a callback pattern or they have to listen to some queue, and now you have to say that API gateway directly pushes to SQS. Somebody else is listening on SQS like an ingestion lambda. It will check if the event is not valid. You somehow still have to communicate to the person, to these services, that dude, you're doing something wrong. Now that is like more effort, more queues, more async patterns, and still you do not know if they are going to act or not on top of it. With this model, I'm actually ensuring that no garbage gets into my system. If the template ID for which the email has to be sent is not valid, I'm stopping right there. Tenant has expired, I'm stopping right over there. Mandatory keys are missing, I'm just stopping right over there. So I've got like less work to manage, because at the end of the day, every event I consume, I have to spend like some nanoseconds or milliseconds. If I can stop it right over there in the gates, it's going to be easy for me to scale this further. No, in this case, if something goes wrong, at least services know they have to retry. If I am doing a rate limiting, they have to stop. Like they know how to retry, right? So at least I have a consistent mechanism to know if at least the event went there or not. That's what I'm ensuring.